Hey guys, happy Friday. Hope that you guys had a good week. We made it to the weekend. If you guys will, if you haven't, if you'll take the survey for me, make sure that you take that. It'll be linked with this all in Google Classroom, just so I can get some feedback and see how things are going. With all distance learning, we only have, I think, about 4 more weeks until we get to come back in person. So I'm really excited about that. Just want to see if there's any changes or adjustments I can make to make the distance learning a little bit easier for you. Anyway, today should be one of the easiest lessons we have all day or all year, or at least so far that we've had. So let's go ahead and get right into it. So we're going to be talking about corresponding and vertical angles with parallel lines. So here we have the intersection of two lines, and when these two lines intersect, you'll notice something about their angles. They form two pairs of vertical angles, right? And we also have some supplementary angles. So first of all, we have to remember, what does supplementary mean? Well, supplementary means, and we can remember by changing this, right, that there are two angles that add up to 180 degrees. So if this is 123 degrees, if we have this straight line here along this line, I guess I could color it so you can see what's going on here. So along the blue line, it's going to form 180 degrees. So if this is 123, what's the missing angle going to be? Well, it's going to be the supplement of 180 of 123. So 123 or 180 minus 123, which is going to be 70 or 57. And those add up to 180, and that's what it means to be a supplement. We can even see that with the protractor. So if we take our protractor, we center it about the vertex, rotate this, and I'll teach you guys how to use protractors when we get back in class, by the way, and all of our other fun activities. Measure out the line. It's going to be 123 degrees. Okay, and I can export that. So that's 123. And if we measured it from the other side, from over here, that's going to give us 53. Whoa, that was weird. Let me change that. How about now? Hopefully that should export as 57. Yeah, there we go. All right, so I'm going to get rid of that. So we got 57 degrees, which we measured over here, 123 degrees, which we measured over here. Wow, that's kind of cool. All right, so yes, 57 is the supplement of 123, but also we also have another line over here that's measured with 123. So let me change that color. Let's do purple this time. And with this purple line over here, we know this also has to be 180 degrees. So if that's 123, the supplement of 123 is still 57. So this angle over here has to be 57 as well, right? Okay, so what that tells us that these two angles here are both the same supplement of the same value, 123, which are both vertical angles. So they both have to be congruent. All right, the same thing would happen with the 123 here. It's a supplement of 57, so the other supplement of 57 has to be 123. All right, so anyway, kind of cool. Hope you guys enjoyed that. All stuff that we've already known before, but you will need to know vertical angles because we're going to be using that all the time and corresponding and vertical angles today. All right, so what are corresponding angles? So when we have two parallel lines, like line A and line B, they're parallel. We know by this little chevron shape, or sometimes it's a triangle, sometimes it's two. Anyway, that's a parallel mark. So it tells us that the two red lines are parallel. So those are our parallel lines. And then we have a transversal. Now the transversal here is in blue. That's going to be line C. And transversal is just going to be a line that cuts the parallel. And if it cuts this parallel, the angles that it forms with the parallel line A are going to be exactly the same as the angles that it forms with the line B. And those angles are called corresponding angles. So for instance, let's see, I take this, I think I locked it. Yeah, I did. So if I take this line here and I move it up here, you'll notice that the angles that it forms are exactly the same. So the same four angles up here are going to be the same four angles anywhere that it intersects along this transversal, as long as those lines are parallel. So the top left angle of 112 degrees is going to be exactly the same as the top left angle up here of 112. If you notice, that angle does not change right here as we move the parallel line on that transversal. So the top left angle of 112 is going to be the same as the top left of 112 here. And those two angles are called corresponding angles because they correspond in the same locations along the transversal of these two parallel lines. Okay, so the top right angle of 168, or sorry, just 68, it's going to be the same as the top right of 68 here. Then we know we have vertical angles, we can fill in the rest, right? So vertical with 68 would be this one over here. So its corresponding one down here is the same, and vertical with that one's 112, and its corresponding on the bottom left there. So notice the four angles up here are exactly the same as the four angles down here. So if we know that we have two parallel lines in a transversal, we can use corresponding and vertical angles and technically supplements or supplementary angles in order to fill in all the rest of the angles. So we only really have to know one of the angles to fill in all the rest. So this is demonstrating the same thing. So angle or lines D and E are parallel to each other. We know that from the blue triangles here. And then F is a transversal that cuts those two parallel lines. Well, the angles formed 1 through 4 are going to be the same as these angles 5 through 8 down here. We see that as I move this up here, it's the exact same angles, right? So angle 1 is going to correspond with angle 5. See that? 1 goes with 5. 2 is going to be the same as 6, top right, top right. 3 goes with 7, those are corresponding, and 4 corresponds with 8. So whatever those values are, I'm going to move this back down here. If I know 2, for instance, say 2 was, I don't know, we'll say it's 70 degrees, then I know 4 has to be 70 degrees because they're vertical, and then that means that 7 and 8 also have to be 70 degrees because they're the corresponding ones. Then the supplement of 70, we'll say, is going to be 110, so this vertical one also has to be 110, and so are the corresponding... It's like a 116. Okay, anyway, so are the corresponding ones down there. So essentially, that's what we're doing. All right, now this one is more complicated because we have 3 parallel lines, all marked by their triangles here, and 2 different transversals. So we know if this is 60, we can't say that this one is 60 right over here because those two are not parallel lines. In order to move across from a corresponding angle here to the corresponding angle over here, that would mean D and E have to be parallel, but they're not. So be very, very careful. We can only move them across the same corresponding angle. All right, so which one does correspond with the 60? Well, moving down the transversal across the parallel lines, the top right goes with the top right and the top right down here. So all 3 of these angles are corresponding. Okay, because they're all in the top right of the same transversal across different parallel lines. So then we can fill in the vertical angles as well. So vertical with 60 would be this one, and all of its corresponding angles, bottom left, are going to be congruent as well. Then what's the supplement of 60? That's going to be 120. So then all of its corresponding angles are 120. And the vertical one of 120 and all the bottom right ones here are going to be the same as well. But knowing one angle, 60, kind of like a chain reaction, allowed us to fill in all the rest of them using corresponding angles and vertical angles and supplements, of course. But we still don't know anything about the angles formed by the transversal E intersecting the parallel lines A, B, and C. But as soon as I tell you one of them, like let's just say that one's 75 degrees, now we can fill in all of its corresponding angles and the vertical ones are all 75, and then find its supplement. So 180 minus 75 is going to be 105. Did I not do that one? I can fix that. I don't know what's happening. It won't let me change it because it's has things going on. Copy. No, it should let me clone it. That's what I just did. That was Command D. Okay, whatever. All right, so that's 105. So is this one. And so all of their corresponding ones. So top right, top right, top right. And what in the world? That was weird. Bottom left, and bottom left. Okay, so once we know one of the angles on any part of the transversal, we know all the rest of the angles on that same transversal in the parallel line and with the other parallel lines. All right, so this one's even trickier because we have 2 parallel lines, 2 different transversals, and they intersect. Whoa, okay, so look at the top left here is 60. So we know right off the bat the corresponding one on the top left here going across the green transversal to the other one is going to be 60. Then the vertical one across here formed with the green and the black line is going to be 60. And the one corresponding down here is also 60. So we filled in all those. The supplement of 60 is going to be 120. So bottom left 120 here. And then its vertical one is 120 as well, which means the sum of these 2 angles is 120, but we don't know what those each individual angles are. That's been cut by the transversal. And just because this is 60 doesn't mean this one here is 60, because the top left and top left are not the same because these are not on the same they're not on the same transversal. The 60 here is formed by the green transversal, where this angle is formed by the blue one. So color coding really helps. So we really can't solve anything else until we know what one of these angles are. So let's do this one. Let's say that's 50 degrees. So the top right formed with the black and the blue is going to be 50, and then the vertical one's 50 here, and then the supplement of 50 is going to be 130 somewhere in there. Okay, there's the 130, which means this one's also 130 here. It's not going to let me do it again. I'm going to have to clone it the old-fashioned way. Okay, fine. Which means these 2 here have to add up to... Is that right? Yeah, so if that's 130, it means that these two angles here have to add up to 130. I'm going to mark those angles. You see that? So we have the bottom right here and the bottom right here. So those have to be 130. So 130 minus the 60 is going to leave us with what's left over, which is 70. I'll move that kind of out of the way. All right, so a little tricky, but totally doable. That's the kind of stuff we're getting into. I hope you enjoy it. Feels like a pattern and like chain reactions. I like it. So 10 minutes, that was stinking awesome, so fast. When we come back on Monday, we'll talk about alternate interior and exterior angles. It'll get a little bit more difficult, but not really, to be honest. And yeah, so fun stuff coming up. Number 4, so if you get out your assignment, we want to use corresponding vertical angles to find the measure of each angle indicated. So first, we have our parallel lines marked here and our transversal cutting across. So what I want you to do, these are actually technically called same side interior angles, and they are same side supplementary, but you don't know that yet. You won't know that till next Tuesday. But instead, we can actually solve all of them using corresponding vertical angles. So what I want you to do is I want you to take the angle that they give you, and I want you to move it across to the other parallel line. So if this is 121, then the bottom left here has to be 121 as well. Now that we've moved it, so go ahead and write that in on the problem. Okay, that's how you're showing your work, because those two are corresponding angles. Now we can solve for the measurement of the missing angle here, because it has to be the supplement of 121. So you can do 180 minus 121, which is equal to, let's see, that's going to be 59 degrees. And that should be one of your answers on the answer bank, and you can cross it out. All right, number 7. Oh, the answer bank is back, by the way. You're welcome. Number 7, use corresponding vertical angles to set up an equation. So keyword, I want you to set up your equation. I want to see your work. And solve for the value of x. Well, spoilers, I already set it up for you. I should have covered that up, but that's okay. All right, so here we have 100 on the bottom right, and then on the bottom right here, across the parallel line, going down the transversal, is the 17x plus or minus 2. So since these are both corresponding angles, it means they have to be equal to each other. So that means 17x minus 2 has to be equal to 100. So we can set up our equation. So go ahead and rewrite that over here on the right of the problem. And then now I want to get the x by itself, so I'm going to add 2 to both sides. That's going to give me 17x is equal to 102. And then to get the x by itself, I divide everything by 17, and that actually goes in evenly, and it's 6, I believe. So your answer is x is equal to 6. I want to see your work. I want to see the steps of your work, and instead of just writing 6. All right, 13. Use corresponding vertical angles to fill in the angles congruent to the given angle, and then find the measure of the angle indicated with the question mark. So same thing. We want to go from 133 all the way to the bottom down here. So to do that, fill in all the corresponding angles of 133. So top right, top right, top right. And you can write those in. Now we can see that these are vertical to each other, so they have to be congruent. So if this is 133, it means this angle here has to be 133 as well. So that's your answer, and you can just write it over there if you want. And that should be one of the answers on the answer bank as well. All right, number 17, last one I'm doing with you. Oh man, it's gonna be a 14-minute video. This is gonna be awesome. All right, so these are technically same side interior angles, which are supplementary, but again, you won't know that till next Tuesday. So what I want you to do is fill in the corresponding angle. Now we could move this one up here, but it's kind of like combined with those two. So the easiest way is just to move this one down there, which I did right there. Okay, so bottom right, bottom right. Now you notice these two are supplementary, which means they add up to 180 degrees. So add the expressions together. Set equal to 180, then we can combine our like terms, subtract 188 from both sides, which will leave us with 2x is equal to negative 8. Then we divide both sides by 2, which will leave us with x is equal to negative 4. And that is it. And we are done. And it's less than 14 minutes. What a happy and a wonderful Friday. So easy. So easy I even thought about skipping this one and just combining it with Monday's assignment. But guys, we're already ahead. We're so ahead we won't even need to do a lesson next Wednesday, which is going to be like an ongoing thing, which makes me really happy. So anyway, if you guys have any questions, I'll see you guys at 11 at our Google Meet, and have a good day.